Greetings, math fans. All right, so today we're going to talk about something called cosine, sum, and difference. All right, and basically what cosine, sum, and difference is going to allow us to do is do some fancy angles like cosine of 15 degrees. Okay, where this is actually the difference of two angles, right? It's the difference of 45 degrees and 30 degrees. All right, or cosine of 75 degrees, which is the sum of 30 and 45. So it's kind of a handy thing to know, and let's come up with our nice little fancy equations. So leave a little bit of room, and the first thing I'm going to draw is our axes. I'm going to draw a unit circle. Ooh, that's not a bad circle. Very impressed. And let's label a couple points on here. This first point right here on the x-axis, we're going to call this point P. And then we're going to label another point here, and that's Q. And then we're going to label a point over here in the second quadrant, and that's point R. And following the alphabet, we're going to, ooh, nice straight line there. And we're going to call this point S. Okay? And let's put some measurements here, or label some things here. This distance here is B. Okay, that angle. And then we're going to go all the way to S, and that's going to be A. And let's do this in a different color here. So if I subtract the two, this distance here is going to be A minus B. All right. So once we have that established here, let's talk about some distances. Let's just kind of throw in a couple values here, just so you guys can kind of see different chords and different arcs that are equal, right? If I said that angle B is equal to 20 degrees, and I said that angle A is equal to 120 degrees, that means A minus B, angle A minus angle B, is equal to 120 minus 20, which is 100 degrees. Okay? So let's kind of put that all in perspective here. I can say angle Q, and we'll call this point O. We need a point here, so we'll call that O. So QOS, do you guys agree that QOS is equal to POR, right? Okay, because QOS is truly A minus B, which is in red A minus B. So QOS is equal to angle POR. So if those angles are equal, and this is a unit, this is on a circle, unit circle, you guys agree that the distance from S to Q is equal to the distance from R to P. Right? So I can say that the chords SQ is equal to chord RP. Okay? So keep that in mind, that these are equal. So if I draw a chord, I don't want to draw it and mess up the picture here, but chords SQ is equal to RP because those angles are equal on that unit circle. All right. So let's talk about this being a unit circle. First of all, if I said cosine of B, right, you guys know cosine of B, I'm just going to pick that as an angle here. Cosine of B is equal to x over r, right? It's our ratio. So if I cross multiply, do you guys agree I get x equals r cosine of B? Well, if r is equal to what? Well, for a unit circle, r is equal to 1, of course. So that means x equals cosine of B. And I can do that for sine of B is equal to y over r. So I cross multiply here, I get y is equal to r sine of b. Okay, so again, y, or r is 1, so y is equal to sine of b. So I can put that as a coordinate for q. I can call that, this guy here is going to be cosine b, comma sine b. Alright, and I can do that now for every one of those. Like s is, right, that angle around there is a. You guys agree with that? So that's going to be cosine of a, sine of a. That's s. And r is going to be, well, it's a minus b. So you guys agree? That's going to be cosine of a minus b, comma, sine of a minus b. Okay, it's kind of a little crunchy to fit all that in there. Okay, so those are coordinates, and of course p, what's p? Isn't that just 1 comma 0? Alright, so once we've established just using sines and cosines, these different coordinates, and on the bottom there, right, I said chords SQ is equal to RP. So if I want to establish some relationship now between all these different coordinates, and I say the chords are equal, what does that mean? If I said the chord SQ is equal to RP, doesn't that mean the distance from S to Q, which I even put on top there, is equal to R to P? So what I can do is I can actually use the distance formula. Alright, I don't have enough room. I kind of have a little bit of room here, but I really want to have plenty of room here to write out the distance formula. So before I erase, or before I get rid of this picture here, I want you guys to understand that the distance from here to here, right, is equal to the distance from here to here. And that's what I'm using. I'm going to use a distance formula, which is what type of formula? It's a Sassy formula. So those two distances are going to be equal. Alright, so let's put this together then. Let me clear this out. Alright, so the distance formula, Sassy formula, so I'm going to say it's cosine of A minus cosine of B squared plus sine of A minus sine of B squared. Of course, this is the square root of that. And that's equal to the square root of, it's going to take a lot of room here, cosine of A minus B minus 1 squared plus the sine of A minus B minus 0, right? That's the y coordinate, quantity squared. So that should all match up, right? Doing the distance formula between those 2 points. Alright, now I need to solve this nasty looking formula here, but it's pretty easy. We're just going to square both sides. And then I'm going to FOIL each one of those out. Okay, I'm just going to do this in one step. When I square both sides, the square root goes away. And then when I FOIL each one of those, I'm going to get cosine squared of A minus 2 cosine A cosine B plus cosine squared of B. Alright, and then square the next one, so I'm going to get plus sine squared of A minus 2 sine A sine B plus sine squared of B. Alright, just because I'm running out of room now, for the next one I'm going to square, I'm going to put on the second line here. If I square that one, I get cosine squared of A minus B, right, minus 2 cosine of A minus B plus 1. And then I square the second set here. That's pretty easy. It's just minus 0, so it's really just sine, so it's plus sine squared of A minus B. Okay? So that looks really nasty, doesn't it? Like everyone wants to drop math right now, but it's really not that bad. What we're going to do is we're going to look for Pythagorean identities. Which, of course, in this one here, we're going to be looking for sine squared of theta plus cosine squared of theta equals 1. So let's kind of highlight some of these guys here. First of all, I see a cosine of A and cosine squared of A and a sine squared of A. So that's one right there. I see a cosine squared of B and a sine squared of B. So that's one there. And on the second line, I see a cosine squared of A minus B and a sine squared of A minus B. So that's pretty sweet. So what I can do is I can rewrite that as I can really kind of cancel these guys out, right? This guy here and this guy here, this guy here, and this guy here. Those are just ones each. So I really have 2 minus 2 cosine of A cosine of B minus 2 sine of A sine of B equals, and so this guy here, that's 1 plus a 1 here. So that's 2 minus 2 cosine of A minus B. Okay, everybody cool with that? The 2's, of course, cancel out because I can subtract 2 from both sides. And then, really what I'm trying to do here, math fans, I'm trying to isolate this guy right here. Okay, this cosine of A minus B, because that's what we're talking about, sum and difference of cosine. And so what I can do is, to solve for this, I can divide everything by -2. Okay, so that puts cosine of A minus B all by itself, and that gives me then cosine of A cosine of B plus sine of A sine of B. All right, this is you need to box this, okay? You need to put some stars around this because this is cosine difference. It's subtracting two angles, kind of like when we did the 15 degrees. This is going to be the 45 minus 30 to give you 15 degrees, okay? So that's cosine difference. Well, I need to come up with cosine sum, and you're like, oh no, you're going to do another derivation, but it's actually pretty easy. If I want to do cosine sum, do you guys agree I can really write this as, cosine sum is A plus B. So I can actually write that as cosine of A minus a negative B. Do you guys agree with that? Right, that's still A plus B. But what that allows me to do is plug in, wherever we see a B in the equation I just boxed, that allows me to put a negative B in there, right? Because I turned it into a difference, but you're putting in a negative B. So I can substitute wherever I see a B, I'm going to put a negative B in there. So I have cosine of A cosine of negative B plus sine of A sine of negative B. And now what we're going to do is we're going to use our negative angle identities. So let me write this out here. So cosine of A plus B. This is going to be our final equation. But I can use our negative angle identities, and cosine of negative B is what? Well, cos is pos. So cosine of negative B is just cosine of B. So you can just rewrite this as cosine of A, cosine of B. And sine of negative B is negative sine of B. So it's minus sine of A sine of B. Okay? So this, math fans, is the other equation that you need to know. So let's put some stars next to this guy here too. Okay? So that's our sum. You got to know these formulas. You don't have to derive it in the middle of a test because that would take a lot of time, but you definitely need to know where it comes from. How do you kind of remember some of this? I always try to give you like little weird ways to remember things. Just remember, well, tomorrow we're going to learn about sine. Okay, and sine is actually going to have the same sign where this is the opposite sign. So cosine of A minus B is got a positive sign in between the two. Cosine of A plus B is a negative sign. So those are opposite signs. And just, here's another weird little thing here. Cosine of A, and here that's the first term, cosine of A. And here's same thing, cosine of A, cosine of A. So you do cosines first and sine second because the sign always is last, right? Because you're always sinning is bad, so you put that at the end. We just don't do that at all. Okay? Anyway, however you want to remember that. I'm trying to give you guys weird ways to remember things. All right, so let's use these formulas now. I'm going to delete this. And let's do cosine of 15 degrees. That's what I initially started off with. Well, what you want to do is you want to figure out combinations of 15 degrees of basically 45 degrees and 30 and 60 degrees. So whatever combinations give you 15 degrees, that's what I want to use. And so I'm going to use 45 minus 30. Now you might say, well, how about 60 minus 45? Beautiful. Doesn't really matter. Okay, you can use whatever you want as long as you get a combination of 15 degrees. So that's equal to cosine of 45 minus 30. All right, so what we're doing is, let me write this on the side here because I think it's important. So cosine of A minus B equals cosine of A, cosine of B, opposite sign, plus sine of A, sine of B. So literally, your value of A is 45 and your value of B is 30. So when I plug that, when I plug it into the equation, I get cosine of A, which is cosine of 45, cosine of B, which is cosine of 30, and then it's plus sine of A, so sine of 45, sine of B, which is sine of 30. That's all you do, and then we got to figure these out. Okay, cosine of 45, root 2 over 2, cosine of 30, root 3 over 2, plus sine of 45, root 2 over 2, and sine of 30, which is 1/2. Now, math fans, these bottom are denominators here, those and those, they better be the same for both of them. That's just kind of how it works out. All right, if they're different, then you didn't figure something out right. So you get root 6 over 4 plus root 2 over 4, and write it as one fraction, so you get root 6 plus root 2 over 4. That's your answer for that problem. It's really pretty easy. Not bad at all. Okay, let's try another one here. Let's do cosine of 5 pi over 12. Brutal, brutal. Well, here it's pi over 12, and what I need to do is I need to figure out combinations of pi over 6, pi over 4, and pi over 3, which are the three reference angles that we know. All right, and what I want you guys to do is just turn it into pi over 12 to see what combination it is. So pi over 6 is 2 pi over 12. Pi over 4 is 3 pi over 12. And pi over 3 is 4 pi over 12. Okay, and which one gives us 5 pi over 12? Well, pi over 6 plus pi over 4. So I now can write that as cosine of pi over 6 plus pi over 4. Okay, pretty easy, right? So that's your A and that's your B. So I can write that then as cosine of A. So cosine of pi over 6, cosine of B, which is pi over 4. It's opposite sign, so it's minus sine of pi over 6, sine of pi over 4. Okay, pretty mellow here. And cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Sine of pi over 6 is 1/2. And sine of pi over 4 is root 2 over 2. So we come up with root 6 minus root 2 over 4. And that's your answer. If you take that value actually and you plug it into the calculator, and then you take cosine of 5 pi over 12, you get the exact same answer. So it's kind of cool. All right, so let's do a little more complicated one here. What about cosine of 195 degrees? Oh man, 195. Okay, you want to use 195. I mean, you could do a combination of 195, right? I could say, 150 and 45, and you actually can figure out 150 and 145. But what I want to do with you guys is show you kind of an easy way to do it, and you're going to use reference angles. It's actually pretty easy. So let's talk about some steps here. The first step is you want to determine the sine of the cosine of 195 degrees. All right, and that's going to be using our all students take calculus. So 195 is down here. So do you guys agree it's negative? Okay, that's the first step. The second step is determine your reference angle. Well, that's pretty easy. Remember, you're either subtracting 180 from it, or subtracting it from 180, or subtracting it from 360, right? Or leaving it the same if it's in the first quadrant. So in this case here, we're in the third quadrant, so we're going to do 195 minus 180, which is 15 degrees. All right, so we've got a reference angle. We know it's negative, so here, our third step, this is our new problem. It's negative cosine of 15 degrees. That's our new problem. That's actually pretty easy. It's negative cosine of 15 degrees. Well, I'm not going to do all that work again because we already did cosine of 15 degrees, and if you look back at your notes, it's root 6 plus root 2 over 4. So our answer then is negative root 6 plus root 2 over 4. But I don't want any parentheses, so no brackets. So what you need to do is you need to distribute. And we get negative root 6 minus root 2 over 4. Just, of course, you distribute just the top, right? I hope you guys know that. Okay, and that's your answer for cosine of 195 degrees. That's pretty easy. Okay, let's do another example here. It's when they get more brutal as it moves on here. So how about cosine of 705 degrees? Wow, that's a hot day. Well, first of all, I don't want to deal with 705. So what can you do? Do coterminal, of course. So we're going to subtract 360 for coterminal. So truly, that's our new problem is cosine of 345 degrees. All right. So now we're going to do our three steps here. First of all, 345 is here, so I know it's positive, right? Because cosine is positive here. And then I'm going to do a reference angle. So our reference angle is 360 minus 345, which is 15 degrees. That's kind of nice. And so our new problem now is cosine of 15 degrees. Right? That's easy. We just did that one. That's root 6 plus root 2 over 4. Okay? Really not bad at all. What about, here's another problem. Cosine of negative 705 degrees. Ugh, it's brutal. Isn't cos is pos? Cosine of 705, which is that. All right? Pretty easy. And of course, if you have, I did a lot of 15 degrees, you might have 75, but just, it's same thing, except it's, 30 plus 45. Okay? So that's actually pretty easy. Just follow the rules, get the sine, get the reference angle, and have a new easy problem. You're good to go. All right, let's do a couple problems where we're working backwards. So if I give you a problem like this, cosine of 5 pi over 13, cosine of 8 pi over 13, minus sine of 5 pi over 13, sine of 8 pi over 13. Brutal. You're looking at it going, oh my gosh, I have no idea what, you never taught us 5 pi over 13, it's crazy. But what you need to do is recognize that this is cosine, it's a minus here, so it's cosine of a plus b. Right? Because, first of all, you recognize it as cosine, cosine, sine, sine, which is our equation for cosine sum or difference, but in this case it's minus, so it's cosine sum. So here's the deal, man, fans. It's really pretty easy. This is A and this is B. That's all it is. I mean, it goes on to the second part here, right? Here's A and B. So if A is 5 pi over 13, what I want, when I say working backwards, I want you to, working backwards means write as a single trig function or single value. That's really what I'm looking for. And so what you're going to do is you're going to say, oh, that's cosine of A, 5 pi over 13, plus cosine, or plus B, which is 8 pi over 13. All right, so that's rewriting as a single trig function. Well, almost. It's cosine of 13 pi over 13, which is cosine of pi. That's a single trig function. Of course, I can simplify this one as a single value. And what's cosine of pi? It's equal to -1. It's like a cyclops if you look sideways at it. Okay, that's pretty easy. Here, I can give you another one. Cosine of 71 degrees, brutal. Cosine of 26 degrees, brutal. Plus sine of 71 degrees, brutal. And sine of 26 degrees, brutal. But recognizing that is a difference for cosine, so it's really cosine of, and this is your A and this is your B, right? So it's A 71 minus 26, which is cosine of 45 degrees, which of course is root 2 over 2. Okay? So working backwards is actually really easy. Just kind of recognizing it, and then you're good to go. All right, so we are going to do, we're going to find our cosine of S plus T and cosine of S minus T given some information. So let's do that problem here. Find cosine of S plus T, and I'm using S and T, that's what the book uses. I don't like S and T, it looks like 5 and plus. Okay, find cosine S and T, S plus T and cosine of S minus T given two things. Sine of S is equal to 4/5, and S is in quadrant 2, and also cosine of T is equal to -5 over 13, and T is in quadrant 3. So I'll tell you, math fans, the key, this is a key, the key is to, you got to make a sketch. You got to sketch each one of these because you have to get the signs right. It's so important. You got to get the signs right, and you got to get your the other side correct using Pythagorean theorem. Okay, so if I sketch quadrant 2, I'm over here, and we know this is going to be y over r, so this is 4, 5. This is a 3, 4, 5. And I'm going to put this in red because this is important. Don't forget that negative. Okay, it's so huge. If you forget the negative, all your answers are going to be wrong. Everything's going to be wrong, and you're going to lose a lot of points for that. So I'm going to be very picky about those signs. All right, so let's sketch this guy here. That we're in quadrant 3, and this is going to be cosine is x over r, so -5, 13, and this is, I'm going to put this in red again. This is -12. Okay, so on the top of your paper, if you think you're going to forget the signs, top of your paper, write the word signs, and then go back and check it. Okay, so in order to do cosine of S plus T or cosine of S minus T, I need cosine S, cosine T, sine S, sine T. You guys agree with that? Well, in the first one, I'm giving you sine of S, so I need to get cosine of S. Well, what's cosine of S? It's -3/5. Okay, it's pretty easy. And in order to get, and then I have cosine of T, I need sine of T. So sine of T is going to be y over r, so it's -12 over 13. So here's the deal, math fans. I have sine of S, I have cosine of S, I have cosine of T, and I have sine of T. And when I actually want to come up with our equations, cosine of S plus T, that's cosine of, I'm going to write it out here, cosine of S, cosine of T, opposite sign, minus sine of S, sine of T. So literally, we're almost done here. Literally, you're plugging in. When you see cosine of S, you're substituting -3/5 for it. It's so easy. Cosine of T, you're substituting -5 over 13. Now notice I don't have cosine of negative 3/5 and cosine of negative 5 over 13. Truly, cosine of s is negative 3/5. Cosine of t is negative 5 over 13. Okay, so let's keep going here. Sine of s is 4/5. And sine of t is negative 12 over 13. And notice when I'm going to put these guys together, I have the same denominator for both of them. So I wind up getting 15 over 65 plus 48 over 65. So that gives me 63 over 65. That's your answer for cosine of s plus t. All right, it's pretty easy. For cosine of s minus t, I can fit it over here. Cosine of s minus t. Do you guys agree it's this exact same thing except for what? That sign's change is plus. So I can do all my work, but I'm not going to. Okay, I'm just going to change this sign right here to plus. So I get 15 over 65 minus then, right? Minus 48 over 65. And that gives me negative 33 over 65. A lot easier. I mean, you could have done the whole thing again, but again, you want to be somewhat efficient in your work. All right? That's pretty easy. All right, I want to do one more example of this, just with a couple of radicals in here. All right, so you're given sine of s is equal to negative 4/7, and s is in quadrant 3, and cosine of t is equal to 2/5, and t is in quadrant 4. And again, I want you to find cosine of s plus t and cosine of s minus t. Okay, so make a quick sketch here. Pretty easy. We're in the third quadrant, so we're here, and label everything. So this is, of course, y over r, so it's negative 4, and this is 7. And using Pythagorean theorem, we're going to get negative root 33. Again, don't forget the negatives. Okay, this is quadrant 4. And this is going to be x over r, so 2/5. And then this is going to be negative root 21 over here. All right, so we're going to do cosine of s is equal to negative root 33 over 7, pretty easy. And sine of t is equal to negative root 21 over 5. We're almost done here, right? It's, again, cosine of s plus t equals cosine of s, which is negative root 33 over 7, cosine of t, which is 2/5, and then it's plus s plus t, so it's minus sine of s, which is negative 4/7, and sine of t, which is negative root 21 over 5. Gosh, that was relatively easy. So we're going to get negative 2 root 33. Same denominators, right? We got 35 on the bottom. So negative 2 root 33 minus, because it's 3 negatives, so watch your signs, minus 4 root 21 over 35. Can't simplify it anymore, so that's it. And of course, cosine of s minus t is equal to, you're just changing the sign, right? So it's going to be, instead of minus 4 root 21, it's going to be negative 2 root 33 plus 4 root 21 over 35. Pretty easy schmeezy. All right? So that's it, math fans, for cosine sum and difference. And I said the next topic is going to be sine sum and difference, which is somewhat easy and similar to today's lesson. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.